Hello guys and welcome to this lesson. Today we are going to see how to write a PLC program for Star Delta Motor Start. Star Delta Motor Start is very common in industrial control system. With large motors, when connected in the Delta configuration, a motor can absorb up to 5 times its rated current at starting. This could lead to serious issues in the building electrical system, sudden power drops, and equipment damages. On the other hand, the Star configuration allows the reduction of the inrush current to approximately 1/3 of the motor rated current. Thus in the Star Delta, the motor is first wired in Star configuration, then switches to Delta after a time delay. This configuration actually allows large motors to avoid huge initial current at starting and run at its full load when connected in Delta. Here is the electrical diagram of Star Delta Motor Start. As you can see, we have 3 contactors. The main contactor is wired permanently to the motor terminals U1 V1 W1. Meanwhile, the second and the third contactors are connected to U1 V2 W2 by turn. Thus while KM3 is off, KM2 ensures the Star configuration. After a time delay, KM2 is deactivated. The motor switches to Delta through energizing KM3. Before we move to programming, it's noteworthy to mention that on the right is shown the control diagram of Star Delta Motor Start without a PLC, and it's very common in industrial systems, especially for standalone ones. Still, since the primary focus of this section is on programming, what we have just seen is a broad idea for fresh student in industrial automation. By the way, relay logic and basic concepts in industrial electricity will be covered in a dedicated section. Here is shown a basic wiring of Star Delta Motor Start with a PLC. As you can see, we have 2 push buttons as inputs, one for starting and the other for stopping the motor. As to the outputs, we have 3 contactors: KM1 the main contactor, KM2 for Star wiring, and KM3 for Delta wiring. The program will be as follows. When we press on the Start push button, the main and Star contactors will be energized, hence the motor runs in Star. After some seconds the Star contactor is deactivated, the Delta contactor is energized, so the motor switches to the Delta until we stop the motor with the Stop push button. The motor generally switches from Star to Delta when it reaches its full speed, therefore the time delay depends on the motor characteristics. As usual, before we start programming, we first enter the process inputs and outputs in PLC tags. This time, we use another way. We head over on device configuration, we click on properties, then by clicking on I/O tags, as we see clearly here, the whole PLC inputs and outputs show up with their respective addresses. We enter now our process inputs and outputs. Remarkably, unlike in the PLC tags folder, here the tags are listed as they are in the physical PLC. We go back to the main OB to start our program. We saw earlier in the video how the process works. For this we can use an SR flip-flop, assigning the set to the Start push button and the reset to the Stop push button. Into the flip-flop output we put the 3 contactors and the conditions that activate each one. Hence we use 2 open contacts for the Start and Stop push buttons, coils for the contactors. We are done with the main contactor. Now we open 2 branches for the Star and Delta contactors, then we work on the conditions that activate and deactivate them. As to the star contactor, it turns on with the main contactor, after some time it turns off. So we can use here an off delay timer. We assign first the timer's address and enter the preset time. We put for example 3 seconds. The delta contactor turns on when the star contactor is off and when the preset time is up. So we use a closed contact having as an address T0, which is nothing but the timer's address. This means that when the timer is active, the closed contact keeps the delta contactor off. This one turns on just when the timer is deactivated. Good. No errors reported. We can move to simulation. Normally, a single press on the start push button will activate the main and the star contactors. After the preset time is over, the star contactor turns off and the delta is activated. A press on the stop push button will deactivate all 3 contactors, hence turning off the motor. So let's test the program. As we can see, after clicking on the start push button, the program did not work, not all the way we expected. Moreover, only when we deactivate the flip-flop with the stop push button that the timer starts working, since the timer is activated with a negative edge, which is not appropriate for our code. As a result, all we need to fix the program is changing the timer. We get another one and see the results. Let's pick this one, supposing that we have no idea how it works. By the way, to be familiar with the software different timers, better to put them in practical examples and change the timer if it is not appropriate for the program rather than checking its diagram, what would seem tedious and time-consuming to the students. Well, another missing thing in the program is the interlock. As you know, KM2 and KM3 should not be active at the same time. We drag 2 closed contacts before KM2 and KM3 and give them their right addresses. We compile the program to check errors, then we load the modified program to PLC Sim. Good. No errors reported. We launch PLC Sim and test the program. Now we click on the Start push button. Normally KM1, KM2 will turn on. After some time we shall see KM2 deactivated and KM3 turns on. To turn the motor off we press on the Stop push button. We test the program once again. The program ran as expected. Clearly, so far we used the SIMATIC timers and yielded excellent results. Now, let's see the difference by trying the newly integrated timers. As we saw in the lesson about timers, the new timers differ from those of SIMATIC ones in that they are supplied with data blocks. In this example we will see how the way they are used in a program code. We pick the TP timer supposing that we already know how it works. Since the aim of this maneuver is showing how the data block timers are used within a PLC program. Watch out here. To use a timer parameter, we hover over the contact here, then we look up for the timer, then by clicking on the 2 arrows on the right we select the needed one, in our case the timer's output. It's quite different from SIMATIC ones where we put the timer's address. Now we compile the program. Surprisingly, TIA Portal reported an error. Maybe it has to do with the interlock instruction. So let's remove the instruction and compile the program again to see the result. No errors reported. I think your guess is good as mine. The reason why this timer does not allow the instruction might be that it regards it as optional, since we already used the timer's output just before KM3. That proves how TIA Portal is an advanced and reliable software with cutting-edge features. Well, let's test the program. The program ran as expected. Hope everything is clear and make sure to hit the like button to support us to make more videos. See you in another lesson.